right, let's do some graphing. So for both of these, we do want to put it into graphing form. They seem to be pretty nice. So we'll go ahead and move those over. So remember, you need to get y by itself. So I'm going to do the bottom one first since it looks so simple. All I need to do is just move the x over. Remember, you have to subtract both sides by that to make that happen. And then I'm going to graph it. So remember, this is the y-intercept. And then I go up one, down one, over one, down one, over one. I do want to make sure that I am going in the negative direction. And I just want to carefully count it out. I don't want to get sloppy, because when you're using your graphs to solve, it's very important that you're very exact so that you can find out where they're intersecting. So for this one here, I'm going to go ahead and move that over. So I have negative 6y. Don't lose that negative. That's one that just oftentimes gets lost. And then I'm going to divide every single thing by that negative 6. So I end up getting y is equal to 1/3 x minus 1. So I'm starting here at my y-intercept, and then I'm going up 1 over 3. Oh, happy days. Check it out, right exactly on that spot there. So that tells me that the solution to the system, or a point that works for both of them, is 3, 0. There is no other point on here that would work for both. Let's go ahead and look at number 3 and see what happens a little differently with this one. Let's zoom in a little. So I'm going to, again, get y by itself. So again, I don't want to lose my negative. I do want to divide everything by that negative 2. Now it's not an inequality, so I don't need to worry about changing signs or anything crazy like that. So I have 3/2 x minus 3. So we're down here at negative 3. We're up 3 over 2, up 3 over 2, and up 3 over 2. So a nice little graph there. Now I'm going to go ahead and move this guy. Again, don't lose the negative. Same thing, you divide everything by the negative 4. So we end up getting 6/4, which is 3/2 if we reduce that. Think about that for a second. And then minus 3. So again, minus 3, and again, up 3 over 2. So my next line is right on top of that. And so we're trying to figure out what are all of the solutions that work for both of these, and there's an infinite number if every single point on this line works. So we're going to go ahead and write infinite. Meaning not that everything works, but there is an infinite number of solutions for this.